Hi, this is a short story about how I make a graph in Excel for Physics 180. So here's the height and wingspan data. This is the clean data. So I selected all of this, and then under Edit, there's a copy button. So if I switch over to Excel, I can paste all of that data. So I'm just going to paste it. So I want to make a plot, and I want to see what the data looks like. So here's how I make a plot. Under Insert, I'm going to insert a scatter graph, and it selected all of this data automatically. If I don't like how it selected all that data, I can instead just insert a chart that's empty. And then under Select Data, so that was left mouse key, right mouse key, select data, I can add a data series. So the X values I'm going to use are height, because I think height predicts wingspan. The Y values I'm going to use are here. And then I'm done. And I'm done. So here's all my data. Now I need to label some stuff. So I need axes titles. I don't need a chart title. I like grid lines. Yeah, this is pretty good. So in this, let's see. When I selected this, I said that height in inches was the X variable, or the independent variable, or the input variable, and wingspan in inches is the output variable. And if I want to double check, not that. If I want to double check, I can select all the data and I can edit the series. And that's where I can double check that the X values are the B column. See, here's B, height, B, X, right? So that's how you can double check and see what data is what data. So then the math model, let's see. If you right click on this, you can add a trend line. And the trend line that I want to add will definitely be a straight line. And I want to make sure that I display the equation. All right. So there's the equation. One person actually told me that you can click and label all of this. So look at that. Wingspan equals that number times height. So there's my math model. Now, if you're going to do all of that, you should probably also label the units. This is in inches. And the only drag about that is that it's hard to label the units of this slope. So I might do that on a separate piece of paper. Now, once I've got this model defined, I could just get out a calculator and work out what the predicted wingspan is for these three kids. Or I can use Excel as a giant calculator, and that's what I did. So in this cell, I just clicked on the cell and then I typed equals, and then you can just type this out like a calculator. So I'm going to say this, to deploy this model, the wingspan, so the model predicts the wingspan to be 1.0749, so that's right here, times the height, that's right here. So I just click in this cell, and that's where I get B4. And then I say minus 5.3026 because it's there. So just to show you that that's possible, let's say equals, I click here, times 1.0749 minus 5.3026. So that's how you can use Excel as a giant calculator. And that's what I did. And then here's what I would expect you to turn in for this problem. So the graph, the fit line, the model, I've labeled these. Just a note, sometimes this is called the Y variable or the dependent variable or the output variable. Those three things all mean the same thing to me. The model is predicting this wingspan. And the model takes as an x variable, or an independent variable, or an input variable, its height. And then notice I've labeled the units. And so then for my calculator, it looks like the model is half an inch off, half an inch off, and an inch and a half off. So I feel pretty good about that model. I had my wife measure the kid's real wingspan. That's it.